Computer.
Hi, everyone. Thanks for being here today with Technology Envoy. We're going to talk a little bit about some of the work of Ken Shoulders, and I'll give you a little bit of background. I interviewed Chris Beskar, the CEO of Stevati Aerospace, about 3 times now, and have had personal contact with him for quite a long time. And it was probably a few months ago that Chris sent me a big package that had all of Ken's patents and all of his research. So a couple of weeks ago, we went through the first one. Today, we're going to go through another one, and we're going to kind of continue on as we move along through Ken's research. And Ken and Chris Beskar were business partners. Chris is the CEO of Stevati Aerospace. And Ken Shoulders was also good friends with John Hutchison. And John is, well known across the world for the Hutchison effect. And we talked a little bit about some of that research when we recorded the other time. So we're going to let Brandon just kind of read. And if anybody's got a comment or they want to add, just kind of jump in as we move along here.
Okay, thanks, Eddie. Okay, I'm just going to read. I'm going to read these slides as they come out. Okay. So low voltage nuclear transmutation work in progress. Completion expected by June 2024 if sponsor is found. By Ken Shoulders, Bodega, California. Okay, so
Um,
this, go on, Eddie.
yeah, I should actually mention the fact that Ken is he designed the cylindrical ion trap mass spectrometer. And that's what this slide is basically showing. There's a few things on the slide that I want to bring up. The lap surfaces is one of them. Um, we have these things when we measure to like a thousandth of an inch or less than that. We have these things called gauge blocks that we can ring together, which means that the lap surfaces are so perfect that when you put the two metals together and give them a twist, they actually adhere to each other and they don't come apart. So that's what the lap surface is here. He's also got silver coating on the outside of this, which is kind of interesting, where the electrode goes into. And the cavity itself is a spherical pocket in ceramic. And then he's got an exit for the ion exit aperture there. So that's what this basically is. This is just them showing us what we're about to see here in the next slides.
I can read off the labels if you like, Eddie.
Yeah, for
So
sure.
this
That's
is
a great
ion
plan.
source. First label shows inserted electrode, silver coating, zero point 0.1 of an inch in length, aluminium substrates, lap surface, spherical pocket in ceramic, ion exit aperture, and cavity.
Yeah,
Okay.
yeah. So if we go to the next one, it sort of shows a little bit more of the of what he's doing here. Um,
EV reactor and cylindrical ion trap mass spectrometer.
and
EV reactor with slide valve. Two views of cylindrical ion trap mass spectrometer.
EV stands for electrovalidium, but there's a whole bunch of names that they use for charge clusters, and I just tend to say charge clusters, just so that everyone kind of understands. And basically, he's trying to build a source for these charge clusters. And then also, in the process of working through all that, he designed this mass spectrometer, which is pretty incredible, actually, because they're used. Brendan, you could probably talk a little bit more about what they do with a mass spectrometer, but
Um, I'd have to look up some background for that to just talk. I don't know if I could talk just off the top of my head on that,
okay,
but
yeah, I think the next slide will actually show us quite a bit more, because what they're doing is they're looking for they're analyzing and looking for different elements, essentially, right?
Well, we could.
That's
Do you want me to go to a Wikipedia page and just read a brief paragraph on mass spectrometer?
yeah, that would be cool. Sure.
Okay, let's do that then. Okay, so mass.
So this is something that Ken would have developed along the way.
Mhm.
I know that Ken was Chris's business partner, but I actually don't know too much more about um, when that happened and why it happened, kind of thing. And I will interview Chris again in the very near future here a few times and ask him a few more questions.
Okay, so a mass spectrometer is an analytical technique that is used to measure the mass to charge ratio of ions. Results are represented as a mass spectrum, a plot of intensity as a function of mass to charge ratio. Mass spectrometry is used in many different fields and is applied to pure samples as well as complex mixtures. Okay.
Yeah.
Let's go back to the thing.
So basically, Ken was the inventor, the designer of this, right? Which is pretty incredible.
That
Um,
is a big deal.
yeah, exactly, right. And
But
Chip
he was
had,
also the inventor of the quadrupole mass spectrometer, as well as the discoverer of EVs. It's a
yeah,
really big deal.
yeah, and also, I'll say this: a lot of people have heard the term zero point energy. Well, Ken Ken Shoulders coined that term. That's where it came from. He's really the father of all of this stuff.
The
And
father
again,
of microelectronics screening as well.
yep, that too. Yep. He
Mhm.
worked for lettered agencies a whole bunch, and that's why I don't know the whole story, and I don't know that Chris will ever maybe tell us all of it, but he has, told us a lot about Ken. And yeah, it's pretty amazing stuff, right? Vacuum microelectronics as well. I don't know if Ken actually worked at Area 51 with Chris or not. That's stuff that I'm going to have to ask him about because Chris, in a text fairly recently, said that he was willing to talk about Area 51. So I don't know how much he's going to reveal and how much he can because of his security clearance again. But it's really cool that we actually have his business partner giving us this information so that we can go through it, right? Yeah. Okay, so on to the next one.
Want me to read it out?
Yeah, for sure. This is
Finding,
basically showing the results of what he was working with, the mass spectrometer.
okay, finding what's new. Three overlapping spectra of titanium isotopes shot into a target from an EV gun at time intervals of about 1 minute produce distinctly different patterns due to the different abundance of isotopes on the target. 2. The data is collected as XY data using a Belleman PCS 500 digital oscilloscope. The data is then processed by Excel to produce this chart. Number 4, differences between the traces can be determined by using the math capability of Excel. So on the graph, it points to titanium mass 48 peak. And on the x-axis, we have nominal mass number. And I assume that what would the y-axis be, Eddie?
Well, I think the
Mass.
like the intensity of it, right? Because they're showing a peak of titanium. Just trying to think about the word, but what you can see is the different colors with that titanium peak, and basically he's saying that they're not quite all the same due to the difference in the abundance of the isotopes on the target. So he's just showing us essentially how this machine works. And then if we go on to the next one, this is the one that I'm most excited to show you guys and talk about because you can actually see with the arrow on the right hand side, if you follow that arrow down, then you can see the EVO striking and then coming out the other side with that thin streak where again that right arrow is. and you can clearly see what is going on here, right? But these are all EVOs coming into an aluminum foil target, essentially. Yeah.
I'll read it if you like.
Yeah,
Edge
betcha.
view of coated aluminium foil being struck by EVOs. Barely visible output from pure metal strikes. Energy release is function of proper EVO loading. Thin bar streaks both ways. A propulsion effect is basis of grain. So
Gain.
the
Yeah,
bottom arrows show thin streaks, the top arrows show incoming EVOs.
yeah. So you can clearly see they talk about EVOs being used as propulsion. Well, if you look on the lower right hand side, you can see they almost look like little rockets, or the what they're producing there. So this is and this is real pictures of the EVOs coming in and stuff, right? This is fantastic to have this type of thing directly from his business partner Chris gave us this, right? But you can clearly see that red line where it says thin streaks and the interactions with the EVOs and whatnot here. Yeah. And the next one, he gets into something. He's basically showing the plasma plume, or when the machines are operated, what you actually see here, which is pretty interesting.
I'll just read it.
Yeah,
EVO plume generator. Single metal strike barely visible. Dense metal plasma strike 500 times brighter. Dual synchronized EVOs produced increased brightness. So for figure 8 on the top left, we have front view of plasma plume with cover removed. Figure 9 on the top right-hand side, side view of plasma plume with cover. And in the bottom left, figure 10, plasma plume with apertures installed.
yeah. So
Hey, Ed, Brendan, I've got a quick question.
yeah,
I just wanted some clarification on this from a slide. I think it was 2 slides ago. Is this what what role exactly is titanium taking in this? Is this titanium ions?
yeah. I think yeah, titanium isotopes. I think he's just basically showing us the function of the mass spectrometer with what he shows us with the titanium. I know that they've experimented like with aluminum and titanium and lots and lots of other metals when they do these types of things. But I think that specifically is meant just to show us the peak that titanium has with whatever they were testing, and showing us how the machine works and whatnot. This EVO plume generator, do you have any comments to add to that?
This one here, you mean? This one here.
Yeah, yeah. It's very, very interesting. I think they're trying to show us the well,
I
they're
guess my question is, what is the composition of this plasma, if you happen to know?
of this plume generator. Um,
Same question.
yeah, I think the next slide might talk a little bit about it, but I don't know what exactly they're doing here, right? The next one talks about a plasma focus,
Okay,
and this is yeah,
Do you want me to read it? Okay,
yeah, yeah,
plasma focus, gigavolt output for 4 kilovolt input, electron cluster generation unrecognized, PF commercially available for transmutation, off-axis transmutation, single EVO capable of greater than 50 kiloelectron volts, output from 1 kiloelectron volt input, superluminal paper by Ken Shoulders, I assume that is.
yeah,
PF scaling effects.
yeah. So I think what he's trying to show us here is 50 kilovolt output from 1 kilovolt input, well, that's a factor of 50 for your free energy, essentially, right? So, Chip, do you have any comments about this as well? You
You
can
know,
see,
the idea is the charge cluster collapses, and I'm assuming that that plume is aluminum vapor of some type. But when the charge cluster collapses, you tap the quantum vacuum field.
yep,
You have a gigantic potential, just like cavitation on a prop. A
yep,
gigantic potential there that's collapsing back to stability, back to the 0 point field. And when it does, out comes all the free energy. And 50 to 1 is pretty damn significant. I'm
exactly.
kind of surprised. Yeah.
Yeah,
So he's firing little potential balls all over the place, very highly potentiated. And the you're poking the ZPE field. And
yep,
that potential collapses, and for a brief moment it will restabilize negentropically, obviously. And it restabilizes, and when it does, out comes that twist, poke, or pinch of the vacuum field as free energy.
yep. And he's also talking about a dual synchronized EVO to produce increased brightness. So that's something that John Hutchison actually did. Is he because of the interference patterns, you can create areas where there's more energy, and he used multiple what were they now? I can't remember now. I think like Tesla coils, but he had multiples of them, but they had to be spaced at exactly the right spacing so that
Yes.
all of this could occur, right? And I think
Yeah.
that's a little bit what he's talking about by synchronizing the EVOs. He's just trying to figure out ways of producing more of them, and how to control them and how to produce them and stuff. And this is work from 2004, so this is 20 years old,
Yeah.
and it's also why we're getting it right now. There's always a lag with this type of technology before the public actually can receive it. So, and 20 years is quite typical, actually.
Yeah, I wanted to see a little bit more, a few more slides to fully digest it, but I think I know where he's going with it.
Yep, yep. So I think the next slide here, they're going to show the plasma focus generator itself. There's a cathode. There's always a cathode and an anode when we do any of this type of thing. So there's the cathode, there's the anode, and then there is also the EV guide, and then the target. So the guide, in my understanding, is a very, very, very small channel or hole that is precisely the proper size. And I think, if I'm correct, it was about 10 to 15 microns. So it's very small, right? And that's actually how he's creating these EVOs, or one way that he uses to create these EVOs. So he's actually showing us the machine that can do the 50 to 1, right? This thing is capable of 50 to 1, and he's saying that this plasma focus was commercially available for transmutation. This is 20 years ago. So nobody probably caught on to what was really happening, because nobody really knew who Ken Shoulders was, I think, back then, or maybe there was a little bit of information, but there's not the wealth of information that there is now, right?
Eddie, we could read that letter out from Bainham if you like towards the end.
Yeah, that would be awesome to do that for sure, right? So I think after that one, the next one is just going to show the actual. This is the actual machine right here, so you can see it's quite small. Those round things are capacitors, and those are going to be the size of a penny probably. So he's got the EVO or the EV target there, and everything happens within that ceramic housing.
Are there 4 capacitors there?
Yeah, I never really counted them.
I've been looking for the quadrupole charge field.
Yeah,
That's all.
yeah, exactly right. Yep, yeah, very cool. So this looks very simple, and it is, but he's getting a 50-to-1 ratio here, right? So this is leading into what the next slide is going to really talk about, and this is where the really good stuff is.
Okay, cold fusion thermal cycling method has EVO evidence. Gas discharge method has EVO evidence. Electrolytic method has EVO evidence. Sonic method has EVO evidence.
Yeah, so the sonic method is the like the cavitation that we were talking about before, and sonoluminescence, I believe, would fall into that category. But here you have an incredible statement in the fact that these four methods all produce evidence of EVOs. So, these guys were on the money when they did all this research. But unfortunately, I don't think they could convey it to the public, because I think he tried, but was unsuccessful in showing that there's EVO evidence everywhere, essentially, in science.
Ed, could you go back to the cutout of the device itself? The
Yeah,
cutaway. I wanted to look at that central tube again. There you go. Can you blow that up at all?
yeah,
Unfortunately not with the Zoom.
Yeah. Yeah, I
Um,
know there's limits on Zoom. Yeah, I was looking at the EV guide and wondering if it is a waveguide of sorts where you would create a soliton, where you create an acoustic waveguide for the EMF field.
yeah.
I could
That's
try
something.
putting it into a paint program and blowing it up if you want me to do that. I can do it quite quickly.
It's
So
That's
Ed,
all right. Yeah,
it,
I'll put
it's
my glasses on and stare at it.
I think it is definitely that. From the stuff that I learned from Chris Beskar directly was that they had this thin needle, and I've talked about this before with you, Chip, before. I think they have this really thin needle that was hollow. So it's very similar to what we've got here. And it had to be a very specific size. And as the thing basically creates itself, it does, like you said, it twists itself up there. So there's a spiral motion, and then it comes out and forms these EVOs, essentially, right? And that was, so it is like a waveguide. You mentioned waveguide. It definitely is like that. And it's really, really small. So I know that when they use the hover car, the plan is to have lots and lots of these little needles that produce these EVOs, and that's going to be sandwiched in the double hull design of the hover car, because there's an inner hull and an outer hull. In all the magic, the engine, the drive system is actually within the hull of that. And
Yeah, and I've seen Sal Paez's patents, very similar with the
yeah,
hybrid underwater aerial device, the Hawk.
yeah, exactly.
Yeah,
Because
electrogravitics. Yeah.
yeah, because actually Chris Beskar and Pete Peterson designed the Hawk at Area 51.
Yes.
Right. That's all they're doing. And we have actual pictures of the Hawk that Chris gave me, and all of the patents. And for those that don't know, in the other group with Dave Rossi, Sal Paez is actually working with Dave Rossi, as is Hal. Isn't Hal Putoff also working with him, I think?
Yes, and Eric Davis as well. Yeah.
Yeah. So essentially what we're trying to say here is, when it comes to disclosure, it's going to come through Dave, as far as the military part of it, and Sal Paez and everything. But all of this stuff was actually developed a long time ago at Area 51 with Chris Beskar and Pete Peterson and a host of others as well. But those are the two main characters of it all.
So Ed, how do you interpret the the definition of the underlying definition of this thing as a transmutation process? What are we transmuting?
Well, from the work of John Hutchison, and I don't know if it actually applies to what we're going here, but I know that there's experiments where they've created a black hole and a white hole. And the black hole is where all the aluminum and metal gets pulled apart. It's an area of destruction. And then there's a transmutation that occurs, kind of like the yin and yang, into the white hole. And then that's where we can produce different elements. And the last Ken Shoulders one that we did, it wasn't Ken that did it, but it was a Russian that Ken was working with or had research with, that shot an EVO through a perfect 99.99% copper. And on the other side, they did analysis, like probably with a mass spectrometer, actually, to figure out the different elements. And there must have been like 20 or 30. Silver was on the other side, gold was on the other side, and it just went on and on and on.
Yeah.
So there was absolute proof of transmutation there, and it's from Russian research again. And I'll always say this, that the Russians never lie and they always tell the truth. So if you really, really want to know about what's going on, you need to look at the Russian research.
Yeah, they're very proud of it. Yeah, it's a very good word. So transmutation is not a generic word here in this case. They're actually creating, at a molecular level, they're creating different elements. And that's the usual use of the word. I was thinking, well, in a generic sense, you could be transmuting the space-time metric and producing 0-point energy also. But that's not the case. One of the questions I've had, and this comes from interactions we've had with this group called the J Collective, is how much they stress spin clusters as well. And I think we brought this up fairly recently, not just charge clusters, but spin clusters, obviously, in terms of hyperdimensional physics, that will allow you to change the flavor of quarks at a subatomic level. And once you do that, you now can create new materials as well. So I suspect there's also spin clusters involved with these charge clusters.
Well, charge clusters are...
What is spin clusters? What is spin clusters?
Well, charge clusters essentially are all spun up. So I think you're kind of talking about this one and the same thing, actually.
I hope so. Yes, I don't want to separate it.
Yeah, no, you are, because we can actually bring up some of the stuff, the charge cluster pictures that I was talking about, like the page that fell out on the floor, and then some of the other stuff that I found from Bob Grenier and even Wheeler's work back in 1954. All correlates to all of this. Yeah, we could do that after, and we'll read that letter as well too. So yeah, definitely, because we're almost done here, and then we'll get into that letter. So basically, what Ken is trying to convey to everyone, because this was done in 2004, is that this stuff all works and it's working technology, but nobody really picked up on it, including the letter that we're going to read, as you'll see. What is a spin cluster? I think it's all one and the same. And once we get, Gabriel, once we get into these other pictures, then it'll be a lot easier to describe.
Yeah. So the charge clusters are spinning like etherons spinning in a vortex to make an electron. The electron has charge, but there's a spin. There's a vortical motion.
Yeah.
So there's charge there, and there's also vortical motion. Vortical motion is a spin sort of thing.
Yep. Yep.
And so a cluster would be like spin, similar or identical spin of the electron charge field. So you could not, in my opinion, you could not create a stable charge cluster without the spin cluster also being homogeneous. It completely phase obliterate itself.
Yeah, no, it is one and the same. And once we get into these other, do you know which ones I mean, Brendan? When I said those ones that all have the charge clusters with the toroid that we went through.
You mean the notes we did a few weeks back?
Yeah.
What do you want me to do? Bring them up?
Well, let's finish this, and then we'll read that letter, and then we'll bring up all of the ones on, if you can find them.
Yep.
Yeah.
So have you finished with this one?
Let's read the summary. Yeah, this one, and then we'll do one more of the summary here, where Ken's sort of talking about.
Shall I go on to the next one?
Yeah, you betcha.
Okay, summary. All listed technologies utilize EVOs as base technology. Thermal output capability only by destruction. Electrical output without device destruction. Notion of proper component design as gain basis. With proper design, Hutchinson effect could function as claimed at the low power actually used.
Yeah, so he's summarizing and saying that you can use EVOs or charge clusters for thermal output, but there is destruction going on when that happens. When they do electrical output, there isn't any destruction. And with proper design, that's where you actually gain the most benefits there. And the last statement with the Hutchison effect claimed that low power is absolutely awesome because he's talking about, and we went into it a little bit more about LENR, so it's low energy nuclear reactions, essentially. And that just means that these numbers like 50 over unity are very, very achievable with all of this technology. And he's also saying that EVOs are the basis for all of this technology. So if you want to learn now about how it works, you need to learn about EVOs and charge clusters and how they spin and how they're spun up and whatnot. I will say this, that in the other group with Dave, we've had conversations about how we believe that there is only one thing, and it's these charge clusters. And when you spin them up past the speed of light or at the speed of light, that's when a graviton is formed. So, and you can engineer them in positive and negative. So when I talked about the proton, that's Paul's theory. I'm saying that I think that it's just a positive and negative charge of a charge cluster. So that theory might need to be altered or changed a little bit, but I put it out there because that was what Paul had done with subquantum kinetics. So I think that.
Hey, Ed, would you mind if I interject for a moment?
Yeah, absolutely. Yeah.
So if I could bring your attention to that letter that Richard Feynman wrote
Yep.
to Ken Shoulders. I'm just going to read the first part here because it directly addresses your question, Chip.
Well, I can put it on screen so that people can see the letter as well. So
Sure. Thank you.
Yep.
Just
absolutely. And it's so fantastic to know where the letter came from, because Carmen sent it to me the other day, I think it was yesterday, and I was like, wow. And I shared it with everyone in all the groups
That's
that
great.
we have, right? Yeah, it's fantastic.
The letter came via Ryan, Ed.
Yeah.
And I found it on that Reddit link. So if you go back to that that I called the mother lode, there was this, I don't know who they are, but I'd like to reach out to them. It's some researcher who's interested in this, who happens to live, I guess, in or near Philadelphia.
Okay.
And he went to the Philadelphia Institute of Science History and dug up all of this stuff that's archived there about Ken Shoulders there.
Wow.
And as far as I know, they're the person who also took this photo.
Right.
So I'm just going to read this first part because I think this really disambiguates the confusion. Charge clusters require a spin or a rotational vector in order to reach stability modes.
Yep.
That's the TLDR. But here's what Feynman himself said. Dear Dr. Shoulders, when you were in my office, I could not see how 10 to the 10th or 10 to the 11th electrons could be kept as a ball in a vacuum without ions. So I was skeptical and didn't let you tell me about them. I must apologize, for it has come to my attention that it is indeed possible. In a uniform magnetic field, a group of electrons rotating at the Larmor precession frequency feel, from the point of view of an observer rotating with them, a force toward the axis, which is centripetal force, which would in size be equal to the centrifugal force expected from this rotation, but directed inward. Then an electric quadrupole could be used to hold them by repulsion along the axis. As long as the force away from the axis generated by the quadrupole does not exceed the previously noted confining force from the magnetic field. This is just so groundbreaking. If
Yeah,
I read this thing 3 times, and I think it was about on the third time when it hit me like a sack of bricks.
yeah,
That this lays the basis for a a charge cluster accelerator.
yeah, yeah, exactly. If you don't mind, you might as well read the whole thing because we're going to read it anyways, if you don't mind, because this is a spectacular letter.
Sure.
Do you want me to read it, or do you want to read it, Ryan? Do you want to read it, or do you want me to read it?
I can read it.
Yeah, Ryan can carry on. Yeah,
So by adjustment of the size of the quadrupole field, the forces of confinement can be made equal in all directions, just as if there were a density of ions in a vacuum, and a rotating sphere of charge is possible. The size seems to be governed by the electric field available without breakdown, but it looks like a reasonable possibility. And again, I just want to pause and say, this is Feynman saying this,
yes,
that he's saying that there's a reasonable possibility of 2 times 10 to the 11 electrons in a magnetic field of several hundred Gauss. Um, uh, now that I understand how it might work, I should be glad to discuss it again anytime you wish. My informant was the physicist Curtis Michel, who told me that ions were confined this way at the Bureau of Standards. Ions are easier, the electric field needed is less, and B can be raised to, say, 15 kilogauss.
yeah,
Some work of this kind was started 10 years ago at UCSD by a Professor M. I forget the full name, but at first the phenomena seen were not understood. I again apologize for my skepticism, which prevented me from from hearing about something very interesting. Sincerely, Richard Feynman.
yeah.
Uh,
And Richard
so
Feynman is a real heavyweight in the area of physics, guys.
yeah,
And then this is Feynman apologizing to Ken Shoulders for not listening to him talk about charge clusters.
and it's on
Right?
Caltech letterhead too.
Yeah,
So
exactly.
why did Feynman ignore it the first time? What
I
did he
think
object to?
he out of hand he must have thought that the Coulomb repulsion, the electrostatic repulsion, would be too high, and that you wouldn't be able to get a stable configuration.
Yeah,
Until later he realized independently that it is possible as long as you have an axis of rotation.
yeah,
Imagine that.
yeah,
We're talking about Dan Winters, implosive compression all over again.
yeah, yeah, exactly. Right. Yeah, it all fits together. So
There,
this letter is like you said, gold. Like this is it right here. This is Richard, saying to Ken, I'm sorry that I didn't really focus in on your work. And unfortunately, that is the case of what happened with Ken Shoulders, and why we're talking about it now and not 20 years ago. But of course, the deep state always had their deep claws into everything, and they would have, in one way or another, stopped it from happening, essentially, right?
That's
So,
also exactly why I took the opportunity to share this with all of my former colleagues at Berkeley Lab, because they
yeah,
deserve to see this and to know about it
yeah.
for sure.
hey
Everyone,
Eddie.
yeah, Gabriel, yeah,
Sorry. Yeah, I want to add an extra possibility here for the
okay,
stability of EVOs. Because, yeah, you guys are saying about rotation, but I am reading a theory. Uh, it is an extended theory uh, without the Gauss condition, Lorentz and Coulomb Gauss condition. And in this theory, you have a scalar field, and this scalar field, it seems that with this scalar field, you can have the EVO stability. So when you create implosion of electric charge,
yeah,
these charges will start to repel initially by the Coulomb Coulomb force,
Yeah.
but when the charges do it, it creates a force in it because it is creating a diverging current, and this diverging current drives creates a scalar field, and by this scalar field, it creates an opposite force, um, sending all the charge to the center again. So the thing behaves like a
Mm,
monopole
yep.
expanding and contracting away. So this is another
Yep.
possibility of
And
EVOs.
actually, when once we get through this and get into those slides, where one slide does talk about the monopole a lot, and it's again from Ken Shoulder's research and Russian research. Yeah. So yeah,
So we'll
we'll
go on
bring
to the
that up
next
later.
slide. Is that okay?
Yeah. Yeah, you betcha.
The energetics of these technologies all have a common basis in electron clustering. Plasma focus, Hutchinson effect, Adamenko work, EVO energy production, and transmutation, cold fusion.
So this statement is incredible, actually, when you come to think about it. He's basically saying that all of these things all have to do with charge clusters or charge cluster technology in one way or the other. And again, why didn't 20 years ago, why didn't mainstream science pick up on this? Well, it's because of the deep state and everything that happened. But it's fantastic that we now have the research and we can look at all this stuff, right? So I think that's was that the last one? Yeah, there's one more where he just says to make sure that we do this properly,
Our
essentially.
next era of energy hangs in the balance. Weigh it carefully.
Yeah. And Chris Beskar has said to me multiple times that in the future we will have more energy than we know what to do with. And it comes from all of this charge cluster technology and some of the other pious patents. And that's how they're going to change our economy. If you take all of that out of the economy, all of the energy costs for producing and transporting and this and that, the cost of things should come down dramatically. Like I would think about 2/3 or maybe half the cost is just tied up in energy itself, whether it's power the lights, put the machines on, whatever. But he has said that we'll have so much energy we won't know what to do with it. So then that takes the energy out of the equation, and now the economy is gonna thrive.
But also, it's like if you've got an over unity device 1,000 times over unity, $1 of energy in produces $1,000 out. So
Yeah,
you'd be creating
that
money
that's a
or
good way
credit
to
or
think
something like
about
that.
it. Yeah,
Yeah.
because in right in here he says 1 kilovolt in is 50 out, right? With the plasma focus. And I mean, Chip, that thing looks pretty simple, really.
It does.
And he's given us all of the information to build it.
Yeah, I'm unusually interested in the tube in the middle of it. That may be the Jesus piece, if you will, and I need to think about that a little bit more. But back to what Brendan just said, a teacup of ZPE is enough to boil all the oceans off the planet.
Yep.
And so that is not an exaggeration. The field is extraordinarily dense, like 10 to the 99th. I mean, it's unimaginable.
Yeah.
And we live in it as a sea of energy.
Yeah. Isn't that the truth? The ether
It kind of solves the vacuum catastrophe, doesn't it?
Yeah.
Yeah, the Big Bang didn't happen. It's an open system, for Christ's sake. So all of cosmology needs to back up and start over.
Yeah.
If I might, Ed, if I had just a few minutes, I'm trying to conflate some of the downloads we received from this J Collective group,
right,
and about spin. And that's why I asked a little bit. I'm trying to understand, and I think Ryan is as well, the stability of the charge clusters. Obviously, Feynman figured out we could put them in a Lorentz field of sorts, a quadrupole field, and keep them stable.
Yeah.
But during phase conjugation of, shearing EMF fields down through Planck, that produces the longitudinal field, there is an adjustment that takes place apparently in the spin of the electrons. And
Okay.
so the bottom line of what we were told in this other group is that quantum gravity is an emergent property of the subasymmetries in time and space. Subasymmetries being subquantum, right? We're
Yeah,
quantum.
because of the gradient. I think that it's a
Exactly.
gravity
And
gradient.
we
Yeah.
talked a little bit about this in Rossi's group. So let me repeat this. The bottom line punchline is quantum gravity is an emergent property of the subasymmetries of time and space. It is not a fundamental force. We only have three fundamental forces according to this group: EM, strong and weak nuclear. Gravity is an emergent property.
Yeah, I
And
would
what
agree.
they're saying is the temporal anisotropy that exists in the vacuum is the driver that creates quantum gravity. And this temporal anisotropy also drives and controls the spin of the electron clusters at the electron level.
Yep. And
And
that's
so
the important part. Yeah.
time in 3D time, spherical time, is the firmament, not space.
Yeah.
And then we can go below that. We start talking about consciousness being the firmament under time and space. That's a whole nother discussion. But what I wanted to peck at just a little bit for a few minutes is this concept that we're missing in the standard model of physics, obviously, time geometry. Standard model of physics does not acknowledge spherical time. We know that's a fact. We know time is three-dimensional. We do not fuck around with 4D time and space. It's six-dimensional. And then, put string theory on top of that, and we got all kinds of problems. But what he is saying, or what this group is saying, is that you create and control transmutation using anisotropic time fields to control boson, spin Z boson fields and leptons. So the spin of the electrons is more important than the charge.
Yeah.
And inherently, if you go down even a lower level and get comfortable with spherical time, three-dimensional time, and the huge amount of anisotropy that exists in there, every little bit of gravity and time variation is going to create an anisotropic time field. It exists everywhere by definition. And so that would appear to be driving the entropy values of these charge clusters, and entropy being their entire charge field and strength, so to speak. So when we ask how do they stay coherent and coming out that cannon that he's got designed there at an even more fundamental than the charge itself, I believe, I don't know this for a fact, it's what I choose to believe. I believe at a more fundamental level is the actual spin of these subatomic particles themselves. The flavor of the quark is what determines the material, that you can change dog shit into gold if you have that figured out.
Brendan, why don't we try and find all those charge cluster pictures, and we'll go through that a little bit.
Do we want to stop the recording, or
no, we can keep going. Yeah.
So what do you want to find again? You want to find those the videos from last time, is that right? Or
no, they were screenshots that we went through when I was showing you guys the charge clusters.
This one?
There was a blue one, and then there was like the charge cluster from Bob Greenier, which was like a blue or red one that had blue background. Yeah, no, that's the one that we did the thing on. We just talked about it in the group a couple times. I don't know if you're going to be able to find the email. I could probably send it again, actually. Why don't I do that? You guys can chat a little bit, and I'm gonna send this to Brendan again, because it's really important that we look at it.
Yeah, one of the comments it goes along with what I was just saying is the quote goes like this: each coordinate in time-space embodies a unique interval entropy value. That's a mouthful. Each coordinate in time-space, not space-time, embodies a unique interval entropy value, where time is controlling the fundamental entropy. Oh, and by the way, it's reciprocal. So we're talking about neg entropy as well. Very important. The entire universe tends to perfection, right? Thank you, Dan Winter. Neg entropy. We can then model the spin entropy as a function of T, X, Y, Z, of spherical time. Okay, so when I read that, when it was presented to us, I was stepping on my tongue because this pretty much turns upside down the model we have of space-time. And obviously tensor space is three-dimensional. As human beings, we have no problem with that. We see that. We do have a problem with three-dimensional time. We live in linear time. But as it would seem, past, present, and future all occur simultaneously, and where time is squishy as hell. And so from a very elevated position, an advanced position, that these beings are providing this information, they see time as the firmament, and that you lay layers of space on top of three-dimensional time, and that the natural anisotropy, the anisotropic characteristic of time, based on gravity fluctuations, obviously that's relativity, this natural potential in the time field, three-dimensional time field, is what can be used to control spin at the quark level. I'm going, okay, so we're not even necessarily talking about magnetic fields. And Ryan is looked, we went to the Feynman letter, looked at the magnetic fields. I have no problems with quadrupole control of charge. But what this group is telling us at even more fundamental level is the spin, and that can be controlled by time anisotropy. Yeah. And, okay, if we were to figure that out, I think there's some real value in that. But yeah. Christ, we don't even have the mathematics. Stephen Wolfram can't even figure this shit out. How to merge 3D time with 3D space. We've never even had the tools to do that.
Brandon, I just emailed you all of those charge clusters pictures, and
thank you, Chip. Let's just go to
bring that back up, and the last one we're going to go to is the monopole, because I think it is really important to. Let's go to that's the last one. So go to the opposite direction. Go to the front. Yeah.
Again.
Yeah, keep going. It's the first one is going to be not that one. Not that one either, I don't think. I think that's the first one, isn't it?
I could try copying it and putting it in a, or I could put, let me just try copying it and putting it in a image thing.
Yeah, that's a really good one. Ed posted that one the other day in our other group.
Yeah. These are actually we're going to go through all the ones that I posted in the other group, because remember I was telling you guys about the story how I had the 600 pages from all the Ken Shoulders work, and I had it printed off, and one page fell out on the floor. Well, it'll be one of the last ones we look at, but it was from Ken Shoulders, and then I remembered about all this other work that had been done with Bob Grenier and even Carmen, and stuff that we brought in. So I just kind of put it all together, because it's all the same structure essentially, right? And it's a D4D. I'm thinking that Carmen might actually have more knowledge than I have when it comes to that, because she's been following Bob for a very long time. Now I know that. And Bob is the one that we're going to have in the car along with Ryan at some point here. So this is from Wheeler, 1954. I just brought it up because it's basically exactly the same structure that we see from Bob Grenier and from Ken Shoulders' work. And this is 1954, so it does go back quite a long ways, right? If you go on to the next one, I think it'll show.
Right, so that's that one there.
Yeah, so this is the one that Bob Grenier came up with in 2020. And if I'm not mistaken, there's 48 in this structure. Um, and these little toroids, they they spin around each other essentially. So they build these little structures. So you have the main one, which is in Bob's terminology is the D, and then you'll see the D4D in some of these other ones here, but this is essentially the same structure that Wheeler was showing as well, right? And this is how the charge clusters form themselves into these toroidal um, different patterns with different amounts of other toroids spinning with them. But there's also toroids that spin. It, um, so they're spun up, and then they're spun up again and again with these little structures. So if you were to take that apart, you would just keep finding the same structure essentially.
Yeah, there's
So
a
that's
three-dimensional fractalized field there. You got toroids on top of toroid.
yeah,
But on the previous slide, one thing that Wheeler points out, if you could back up just a second, Brennan,
yeah,
he points out that this feature is creating a standing wave. Do you see that in there?
yeah, exactly. Bingo.
Very, very important
Yeah,
because that is the
bingo.
stability that would
Yeah.
seem to be the basis
It,
of stability for the charge clusters. And
and
that's why these are sacred geometries, for Christ's sake. Toroids are really cool.
and having said that, when Brandon does the computer simulations, he's looking for a soliton. He's looking for a standing wave to make it's stable, right, Brandon? When you do
Gift
the
from
actual,
source.
yeah,
Solitons are a gift from source. They're the coolest damn things there are. And
yeah,
so
and
we use
ether
them
and
for
etherons, right?
yeah,
Because it's actually the ether. So I said this to Chris Beskar. I said I think that an etheron, a charge cluster, and ball lightning are all one and the same. But I really should have said I think a etheron and electron and ball lightning are one and the same because it's the electrons that you spin up to form these charge clusters. And he knows about this group, and he said that he really thought that we should follow, this lead essentially and keep going down this path. And that was right from Chris Beskar himself, right? So
yeah.
there's a lot going on here, and it's kind of a combination of all the three groups, like this group, Dave Rossi's group, and Bob Greenier's group. And again, we're going to have Bob and Ryan captured in the car, hopefully, and be able to talk to them, in a couple of weeks.
Yeah.
So yeah.
Just
But you're
one last comment on the Gion here that Wheeler's got. I think we're looking for 0 point energy is a random stable field and just constantly oscillating at 0 point 460 what is it 59 degrees below zero. You have motion. You have a
yeah,
potential field that you can extract energy from. So if this is one of the basic molecular elements of this stable ZPE field, before you poke it, twist it, torque it, whatever, to get energy out of it, then this would make sense because this geometry by definition is creating a standing wave. It is
yeah.
self-assembling, self-limiting, and self-stabilizing.
Yeah.
And I don't want to thank source for that. I'd like to really try to understand it about the barbecue sauce, but we may be looking, this is why charge clusters are so damn important. We may be looking at the primordial molecular secret of the whole universe right here.
Oh, bingo. Yeah, I
I'd
absolutely
like to
agree.
mention something just briefly.
Yeah,
So on a different scale, this is essentially the same problem that tokamaks and stellarators are trying to solve
right.
by
Yeah.
vector addition of confinement fields to form essentially a Taylor state. Taylor state is partly defined by magnetic helicity. If you look up the Dynomac,
Dynamac. Do that. Dynamac. How do you spell it? Dynamac.
Dynomak.
Dynoaka.
Dynomak.
N Nomak.
Right.
Yes.
That was that.
Bring up if you could bring up the Wikipedia for that. There you go. Thank you. Look on the right hand side. That image. If you click on that image, it'll bring it larger. There you
Veromac.
go.
Okay. Wow.
That
Imagine
is
that.
one of the previous experimental attempts to create a stable plasma mode that is toroidal, and it starts off chaotic, but you have these three half toroid
Yep.
areas on the top of the chamber,
Yep.
and those are used to inject helicity into the plasma, and then you have this uh, relaxation of the state into a Taylor state.
Yeah.
Um,
So
I'd
that
like
is
to
very
see this happen again, but with HTS coils, because I'm pretty sure it would actually get to a point where you can reach uh, hot fusion ignition. Um, but nonetheless, it's an interesting
Cool.
parallel there.
Yeah. And isn't there a blue toroid in the center of that forming in the
yeah,
Taylor state?
Yes.
yeah,
Yeah.
that's the secret.
Yeah,
Yeah,
exactly. That is
that's
so
what's
cool.
that's what's stabilizing. So,
Yeah.
if you were to instance use a squid device and look for a longitudinal field coming out of this, it looks like almost like you're phase conjugating an EMF field with the handholds on top
Hmm.
and at right angles. And then you create the helicity, the implosive compression, Dan Winter, that rate of spin as it proceeds to Planck is time.
Yeah.
The spin rate is time. The angular momentum, omega, is gravity. And
Yep.
so, Einstein had that right. We've conflated gravity and time, and no problems with that. Hence, all the temporal anisotropy that exists in the universe that we can now use for various other things. But we just created a stable, standing subquantum element with
Yep.
this, and it was self-emergent. I would also contend, if you have a really good Vogel crystal, that I could create that with my mind.
Yeah.
I can create that toroid in my DNA, in my mind.
Yep.
And so that's what we're supposed to be able to do, right? A la Elena Denon. Thank you very much.
Yeah.
The Altians and the Patal and everybody else. We have this capability of self-creation. And so
Absolutely.
the
Yeah.
fact that it falls out of this kind of naturally emphasizes super force, uniformity, and everything else. It is self-creating, self-assembling.
Yep.
Unified field theory right there.
Yeah. Pretty cool. Thanks for that, Ryan.
Just briefly,
Yeah.
one of the things that really interested me in general about this arrangement, the Dynamac, is it's attempting to create a Taylor state in a plasma at a macro scale, right? This is
Yeah.
a couple of meters across.
Wow.
So that self-similarity across scales crops up here.
Yeah.
And I find that very interesting.
Fractalized.
Yeah. Fractalization. With the Turing wave, it takes about 1 trillion etherons to form a Turing wave. And then when you look at the work of Ken Shoulders, it's around 1 trillion that are required, electrons that are required to form a charge cluster. So here you have fractality again, right? And that's something that I did talk to Chris Beskar about. Yeah, so he very encouraged us to keep moving in the research that we're doing in this group, actually, which is very, very encouraging. But this is super cool. Yeah, definitely. Because it's like Paul was a quantum physicist and an astrophysicist. So Paul did the very, very small, but he also did the very, very large. And there are 29 predictions that come out of subquantum kinetics that over time all prove to be true. And we've gone through about half of them, but we need to go through them more, Brendan. And this is great that you're bringing all this in as well, too, Ryan. Thank you. Yeah,
You just mentioned something that I just found to be really interesting. You said that uh, uh, you need a number of electrons on the order of a trillion in order to create a stable charge cluster.
yeah, yeah.
That's 10 to the 12th. Feynman said the reasonable estimate Feynman made was 2 times 10 to the 11th,
Yeah,
which is in the ballpark.
yeah, exactly. Yeah, because there is kind of a ballpark. Yeah, so absolutely. Yeah, no, that's something that I picked up on, in the last year or so, doing especially the Turing wave, because I've done a whole bunch of podcasts on the Turing wave and what it really is, and then believe this or not,
A
with
trillion is 10 to the 12, isn't it? A trillion is 10 to the 12. So billion
yeah,
is 10 to the 9. Yeah. Okay.
yeah,
Yeah.
yeah,
So
yeah.
so Ed, why would I think I asked this question the other night? Why couldn't you do it with far fewer? What is it about a trillion that's magic? And if we could
Um,
answer that question, we would understand the guts of how the thing really works. That's
yeah,
why I'm asking it.
yeah. And you know what?
Ding.
I actually probably could ask Chris, right?
Great
Uh,
question.
yeah, I am
Why?
going to be interviewing him soon. I was supposed to be this month, but Sam's not with us yet, so we got to wait a little bit. But yeah, that's a great question for him,
And
right?
you see why I'm chaffing at it. If everything is fractalized in a quantum vacuum, then why the hell is a trillion a magic number?
Yeah,
It shouldn't matter.
you asked
It
me
should be
that before,
scalable.
actually.
Yeah.
Yeah,
What the
yeah,
hell?
yeah. And I think there is an answer to that, um, for sure. But we need to do a little bit more research to figure out why, because um,
I don't want to hear that, it has to do with source.
well,
Please, we
that's what I
really
would
need to
normally
figure
say,
this out
right?
on our own.
Exactly. Yeah, for sure, for sure.
Personally,
So,
I think this is a component of uh, uh, the the time frame that Greer said has been set on disclosure.
mm,
You can't stop the autodidacts just hammering it out if the Cold War era fossils are not going to be forthcoming about it.
that's
Just
funny.
leapfrog them.
So
Yeah.
some people think
Yeah.
that if disclosure happens, official disclosure happens, the extraterrestrials will eventually walk among us. It'll be
Well, maybe
proper
don't.
contact with extraterrestrials, their technology, their spirituality. You know, I mean,
Well, there,
if official disclosure happens,
Yeah,
I'll share.
hard disclosure. Yeah, hard
hard
disclosure.
disclosure.
Yeah,
They would
many of
interact
them
with us
actually,
more.
yeah, many of them actually don't walk; they levitate. So that will be a little bit of a shock for someone walking down the
I'll,
sidewalk in New York City. But
I'll share something with you guys that came from David Wilcock. And again, he had that meeting with Trump. David Wilcock said that there are 35 areas under the White House that are being set up for 35 different races. And he will be the first ambassador to the first ET thing. Uh, and that's something that he has said. So we'll have to see if that's true or
very
not.
good.
Trump,
But
you said, Eddie. Trump would be the first ambassador.
no, David Wilcock will be.
David Wilcock. Okay. Okay.
Yeah, and this has already been set up with Trump. Apparently, yeah, there's a lot of really cool things in store for you guys, big time.
So
Yeah,
Mary just posted a question: will they wear clothes and live next door? Absolutely, they play
yeah,
like us. I can
yeah,
tell you this: you've already heard this, Mary. Musk is a Solosian, for Christ's sake.
yeah. He's full on ET. Yeah,
Celos is a planet around Beta Centauri.
yeah,
Yeah, and so he's here to expedite disclosure,
yeah.
and it's a wonderful thing. The Telosians live in Mount Shasta; they're an offshoot of the Solosians, but
Yeah.
so yeah.
Brendan, why don't we go to the slides again? Because I do want to get to the monopole part, because it is actually the if you're looking for something that explains everything, we're gonna see it here.
These ones here.
Yeah, yeah. So let's go past. So this is Bob. So it's a wheel within a wheel within a wheel that are all spinning essentially, right? And if we go on to the next one, and this is Bob's work. This is the D4D structure.
That would be a
And
nested toroid.
what I could do is I can blow that one up. I can copy it and
yeah,
put it in
because
the.
this is really important because this actually does show the monopole that we'll get to at the very end, which is ultra important with it all. But this is Bob Greenyer's work, and it's fantastic. And Ryan, you and Paul, if Asteros is still here, you can jump in too as well. But what we see here is the D, which is the large toroid, and then the 4D are the four that are spinning around it essentially. And you can see that cone that goes up into the middle, and there's a flat plane that kind of attaches to all four of those toroids. Well, that's the focal point of the monopole. We're actually looking at part of the monopole setup here. And this is something that Bob has used in his O'Day, which everyone should go watch this one, because this is the one that talks about things a lot. You can also see the other cones that go into the center of each of those toroids, and there's four of them that kind of go around. It's showing the fractality of these structures essentially. So to go on to the next one, Brendan, I think we're going to see actual research that was done.
Let's just copy
Yeah.
that image and put it
Yeah.
in.
So this is actual research that was done by Bob and the other guy that's mentioned here. And again, we see this toroidal structure. And I believe that this was stone that was, they used low energy nuclear reaction, which is LENR technology, to come up with this, some of the experiments that he did. So again, you see that exactly the same structure, right?
So Ed, go back to the previous slide, Greenyer's.
Yeah, the monopole.
Yeah.
Okay.
Is he
So
implying that
this one here, yeah.
yes?
Yeah.
Is he implying that the cones are creating the toroids, or there's the two?
It's
the two need to be merged for stability. I'm interpreting it like a helical collapse, the helicity associated with implosion, phase conjugation, the whole damn thing, and that the toroid is created by this vortical construct that is superfluid.
Yeah, or the ether. Yeah.
The ether is the superfluid, which naturally creates vortical collapse, minute vortices, obviously, all through the entire vacuum of space. And so it would seem that the toroids are self-emergent from that helicity, as Ryan puts it. Well, that's fascinating. Jesus.
Yeah.
Put the whole thing in an egg here.
Yeah, no, this is good stuff. Wait till we get to the monopole at the end and what Ken Shoulders has to say about it all. Yeah, this is fantastic stuff. But you can also see the little red ones that are spinning around the D4D structure. So that's why in Bob's big structure there, you saw, I think it's 48. I think there were 48.
Yeah, the other one. Yeah, you want to go to the other one? Yeah. Okay. Let's go to the other one. Okay, so the one that you did, the one that you were just showing a moment ago. This one here.
No, the red one with the blue background, and that's just, we'll go to that one after, and that monopole and
red one with really the blue important. Background.
It was one of the first. This one. Yeah, that one. So this is something that Bob came up with in February.
Let me just copy it, and then I'll just put it in a thing here.
And you can see the toroids forming around, and then little ones forming within, and so on, essentially. And this is, what is that, more than 4.5 years ago or something that Bob came up with this. He's right on the money, and that's why I like the interaction of all three of these groups together, because I've always kind of known about this stuff because of Carmen, right? I wasn't always listening to all the ones, but Carmen would always send me the important ones, or just intuitively I would end up with them live when they're doing this stuff, right? Because Bob's group is different. There's, I think, 2,500 people usually follow him, And it's not like this call where we can talk to each other and whatnot. He brings on people like Carmen and Ryan. I'm sure you'll probably be on with them at some point as well. He brings in experts and whatnot, and he travels all over the world too, for all of this stuff as well. So he's well worth watching for sure.
Has
So
he ever
let's.
said anything? Ed, has he ever said anything about event horizons associated with a toroid? Natural event horizons. You know, you got a hollow inner core within the toroid. You got a big hole in the middle, the donut hole, and you have an inner and an outer surface that may be event horizons of sorts. And the whole thing is a massive information carrying element, if you will, that is stable because of the geometry.
Yeah, and if you go to that one with the green, Brandon, that kind of does show what you're talking about. I don't know if I've ever heard those words from him, but again, like Ryan and
that
yeah,
Yeah, the egg. Yeah,
yeah,
we call it.
Yeah, you can see the
Russian egg.
You can see those surfaces where those cones point to a bit, basically. That maybe that's what you're talking about, essentially.
I see three-dimensional spin with three different objects, and the whole thing is encased in a massive fractalized unit of sorts. Yeah.
So that was March of 2023. So that's this is a few years old now, some of this stuff. But let's go back, Brandon, to the
What did they call you?
we'll
This
go
morning?
forward a little
Which
bit.
one? Which one? To the
Just go forward into some of the last ones. Like we saw that one. Let's look at this one. Oh, go
this
back.
one here. This one here.
Yeah. No, go back one.
That one.
And then we'll look at that one, and then we'll look at that last monopole one, because it's the most important of all. And again, this is just another experiment where he found this D4D structure, essentially, with the collapsed toroid
Let's try.
cluster. And I believe it's in rock. If I'm not mistaken, I think these experiments were done in stone or like in rock material, from what I remember.
No kidding.
Yeah. So
it's 2-micron scale at the very bottom there. I see that.
It's 8 micrometers, and on the right hand it's 2 micrometer scale. The left hand is 8 micrometers.
Yeah. So we're back into the same sort of scale. Very, very small. The stuff is very, very small, but yeah, it's incredible. And there's a lot more of this as well. These are just kind of the screenshots that I took along the way and remembered that I had and such. So if we go to the last one, we'll have you read this, because this is the crux of all science, essentially.
This one here.
Yeah, yeah. So try and make that one bigger. It says that this can't occur. And here we have Ken Shoulders telling us about it, along with the work of a Russian. So if you want to read through that.
Okay, I'll read it from the beginning. Okay.
Yep.
By some irony of fate, we may have By some irony of fate, we may have folded back upon ourselves, and now have accidentally discovered the EV, as an ideal monopole oscillator. This oscillator is the perfect generator for vector and scalar potential waves, without contamination from either electric or magnetic fields.
Super important, that part. Yeah.
These waves can be thought of as longitudinal waves in the vacuum. They are largely undetectable by standard electric and magnetic detecting means, but are readily accessible to the monopole world. There appears to be an incredibly large number of useful phenomena yet to arise for abusing potential effects that are not immediately accessible to the force of electric and magnetic fields. This phase-determined force-free world will certainly be another chapter somewhere in the future. This one as well? This one as well?
Yeah, you betcha. And I suggest the future starts now, you guys.
Yeah.
So figure 4, which is figure 4, non-radiating configurations. Such configurations consist of a toroidal dipole represented by a solenoid with oscillating poloidal currents and an electric dipole represented by a pair of opposite charges oscillating on the same frequency as the currents. With appropriate phase difference and oscillation amplitudes, destructive interference takes place. The combined source does not radiate electromagnetic fields. However, the scalar phi and the vector A potentials associated with radiation of these dipoles do not cancel, but instead propagate to the far field. Hence, a non-radiating configuration acts as a source of electromagnetic potentials, but not electromagnetic fields. The physical significance and detectability of these potentials are not established and are being actively discussed in the literature.
Yeah, and that's from the Russians' research, which is actually published in Nature, I think, Nature Materials, right?
2016, it looks like.
Yep. But you can see, it's too bad this drawing is not super clear, but you can clearly see the D4D structure there.
Should I make it larger? I'm going to try and make it larger. See if
Yeah, and
larger,
see if you can read what it says on there. I see the bottom part says propagating potentials.
Yeah.
And the other one,
propagating potentials, difficult.
Yeah, it's hard to.
Fields, something fields.
Vandenberg fields.
Oh, yes. Yep. Exactly.
Oh, God. There's a lot of interpolation in that word, but it looks like Vandenberg. My God, we have a scalar wave generator here, for Christ's sake.
Yeah.
Create a longitudinal field. Yes, you can detect these with a squid.
Yep.
Yeah.
Exactly.
I have one being built as we speak.
It's cool.
Cheap. Yeah, and I'll be able to use it for some of our ZPE devices.
Cool. Very cool. Yep. But this is the crux of it right here, guys. The crux of science in a lot of ways, because they say that this is not possible in normal science. Well, here we have it. And here we have it from, Ken Shoulders and the Russian again. Who are we going to believe? Well, my money's on Ken Shoulders big time, right?
Yeah.
And so this is really cool. And it totally, go back to the green one again, Brandon, and look at the structures. They're very, very similar, right? What Bob's got with the green setup, you have your D4D structure there.
So do we know how he imaged these features in rocks?
With Lehner, low energy nuclear reactions. I don't know at what voltage and whatnot, but we're going to have a captured audience in the car in a couple of weeks, hopefully. So there you go, right?
Can I ride in the trunk?
Yeah, I'd love to be in that car too, but no, we're going to have some time with them. So, you got questions, maybe write them down and we can hit them with that, because that's a great question. Where did it all sort of come from and get put together in his mind as well, right? Because 2020, he's got that set up, and then by 2023, he's got this.
He credits Vladimirovich Dubovic with discovering the fractal toroidal moment in his 1967 thesis, I believe, but also people like Alexander Parkhomov, who was like
should be okay with the memory on this video. I think it's okay. We're going. Should be all right. I don't know if there's any limits to it.
Oh, the Zoom call, you mean? Yeah.
No, the Zoom call, the recording. I'm not sure how long we can go on for, but it might be a long time. I'm not sure.
Yeah, we've gone a few hours before with some of the stuff we did with Legia. I don't know how long it's getting now, but yeah. We could hear you a little bit, Asteros. You were there for a second, but we can't hear you now. But Yeah. But so Chip, this is something that I kind of wanted to go through, and I did show the other group a little bit of this stuff. But Bob Greener's research in the Martin Flashman Memorial Project here is pivotal in everything that we are talking about with charge clusters and all of these technologies that are coming out of the Pius patents. But really, the stuff is coming out of Stavati, right? So it's fantastic that Dave is bringing everything out with Sal and with Hal and with Eric. It's fantastic, and it will be the disclosure of these technologies. But the core of all these technologies are charge clusters. Chris Beskar told me that they can deradiate nuclear waste within 48 hours using charge clusters.
Yeah,
Bob,
John Hutchison, Bob, a lot of people will say the same thing, or 2 months in the case of like Fukushima.
yeah,
But he'll also say stuff like, why clean it up in 2 months when you can have a 400,000-year problem where whoever claims they own the land gets paid for it?
Yeah, that's
yeah,
transmutation at its best.
yeah, yeah, exactly. And there's there's a lot of other technologies that all come out of here, including anti-gravity and free energy, because it's actually the charge clusters. And this is right from Ken's shoulders. Things that do the work, actually engage the ether, are these charge clusters, are essentially etherons. We got to start with the etheron, because etheron, in Paul's description of an etheron, he says it's actually consciousness. And I tend to agree with him on that one.
So do
So,
I. Well, that's another 3 hour long discussion, as you
yeah,
know.
yeah, for sure.
I
Yeah.
view energy, electricity, consciousness all as the same thing. Ether, plasmoids, they're all
Mhm.
types of the same thing.
Yep,
Superfield.
I'd agree. I'd agree. So I think it's getting on a little bit long now, so maybe we can stop the recording and then we can have just
Okay.
final thing if anybody's got questions or anything, and then we'll get Brandon to put this up, which
I'll
is
stop it now.
fantastic. Okay.
Okay, great. Well done, everyone.
Yeah, thank you everyone for all your input. And I think that this is really, really important research. In fact, I know that this is the most cutting edge research on the planet, is charge clusters and all of this research that we're doing.
Okay, Eddie, I'll stop it now. Yeah, okay.
Yeah.